So welcome to tutorial session 5 of the course Problem Solving Through Programming in C. This is a NPTEL course or rather a SWAYAM course which has been floated by Professor Anupam Basu from Department of CSE IIT Kharagpur, and I'm Siddhant. I'm one of the 4 TAs who are handling this tutorial classes for this particular course, and in this tutorial classes we'll be discussing some questions, some sample questions and sample problems which you might find helpful while solving your assignments and as well as in the main exam. Okay, so this is tutorial session 5. In this week we came to know more about looping statements and especially break and continue statements and so on. So let us solve a few questions related to that. Okay, so my first question for all of you is as follows. So we have this float variable which is k and it is set to 0, and we have a for statement. It's a looping statement which starts from 0.5 and the condition is k less than 3. The increment is by 1 and it is printing I love C. And so what will be the output of this particular code? You can just write it in the chat box or you can unmute and tell me the answer. So this basically means k is equal to k plus 1. So accordingly, just think about it, how many times it should print. So when initially k is equal to 0.5, when k is equal to 0.5, it will print this statement once. Then the k value increases from 0.5 to 1.5, and for k 1.5, that is the second iteration. So this is the first iteration and this is the second iteration. In the second iteration again it will print, right? Then after the second iteration is over, it will again increment the value by 1 and it will become 2.5. It will print it again. This is the third iteration, and after the third iteration is over, it will increase the value from 2.5 to 3.5. Now when it comes, it checks for the fourth iteration. Before the fourth iteration starts, in while loop you have the condition checking first at the beginning of the loop. So it will check that 3.5 is less than 3, that is false, so it will exit the loop and it will go to the next statement, which is return 0. So here we have total of 3 complete iterations that ran, and we have 3 times this statement was printed. So here the answer will be D. So is it clear to everyone? Okay. Okay. If it is unclear, you can just unmute and just speak up if you have any doubts, or you can write them in the chat box as well. So if not, then we'll be proceeding to the next question. So this is another question which is asking what is the output of the following code, and the code is a do while loop. So we saw 3 kinds of looping statements. There was a for loop, we had a while loop, and we had a do while loop. So the specialty of do while loop is that it always executes at least once. Okay, that we saw in the previous set of lectures, I think week 4. So that is the specialty of do while loop. Okay, so keeping that in mind, let's see this particular do while loop. There is an integer variable I which is which is initialized to 1, and in the do while loop we are printing this particular statement, which is while versus do while, and the condition is while I equals 1. Okay, and then after this loop we are printing another statement which is out of loop and returning something. So what should be the answer in this particular case? Like, just try to visualize or try to run this in your mind and find out what the answer should be. So because it's a do while loop, we know that this while versus do while should appear at least once. So definitely that will appear once. That's what we know. But see this particular condition and think about what should the answer be. Option D. Okay. So can you explain that, Kaushik? Why it should be option D? Okay, yeah. So it's mostly what you have said is correct, but yeah, like one point I had just this doubt that when you say boolean value for while when you give a boolean value of 1 for while, so here actually this is a condition where you are saying I equals 1 and the value of I is actually 1. So this condition will always be true. Okay, is that what you said? Yeah, yeah. Okay, so so this is a condition which is I equals 1 and we have set the initial value of I to be 1 and we are not incrementing or decrementing it anywhere, as you can see. We are not writing I plus plus and I minus minus anywhere. So the value of I stays the same across the iterations. And here, because our condition is I equals 1 and I actually is equal to 1, so this condition is always true. So as this condition is always true, this loop will continue running till infinite time. So this is what is called an infinite loop. Okay, so it will keep printing this particular statement, that is while versus do while, for infinite time. So it will not exit at all. It will not reach this printf out of loop statement itself. It will be infinitely looping in this particular section. Okay, so the answer here will be option D. That is, you'll get while versus do while infinite times. Okay, I hope that is clear. So, so this is a way in which you can write infinite loops. So infinite loops can be written in all these looping statements. So if you want to write, say, an infinite loop as a for loop, you can simply write it like this. So this is a infinite for loop, nothing else, like just this much. So you have no initial conditions, no uh, like no initialization part, no conditional part, no increment part, and it will run forever. So this is an example of a infinite loop in a using a for loop. Okay, so you can write infinite loops using all for loop, while loop, do while loop, any of them, but it's not necessary that any do while loop will be an infinite loop. Okay, 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 let's see a few questions regarding flow control. So flow control statements that we have seen are break statement, and we have another called continue. So what does break statement do? Break statement uh, brings the uh, brings the flow outside that particular loop, right? So that is what the break statement does. And continue, what does it do? It skips the rest of the lines and moves to the next iteration. Okay, so this basically is the purpose of using break statements and continue statements. If we want on fulfillment of a certain condition, if we want the flow to come outside, the program to come outside that particular loop, and not keep processing or executing the lines. So and then we will use a break statement. And say you want to skip a particular iteration in between on fulfillment of a certain condition, you will use the continue statement and with the if statement, so that if that particular condition is satisfied, it will skip that iteration that you want. Okay, it will move to the next iteration. Okay, so let's see this particular question. So what will be the output of this particular code? We have I is equal to 0. We have initialized it. And as you can see here, this seems like an infinite loop definition for loop that I showed to you earlier. But you see inside the loop, we have a few things. We are incrementing I somewhere. We have a if statement with a break condition. So with a if statement with a if conditional with a break statement. So this more or less it suffices to have a full for loop. So you can figure that out yourself. First, you solve this particular question, then I'll show you how exactly this for loop has been written. Like how else we could have written this particular for loop in a much simpler manner. Okay, so just try solving this. So this is a pre-increment operator, so it will increase the value first and then it will print. So just keep that in mind and try to solve this. Okay, and we have different answers here. Okay, fine. So cool. Okay, so let's run this entire loop and see what it is giving us. So this is the initialization step, that is I is equal to 0. Say in the first iteration, when I'm talking about the first iteration, I is equal to 0 here initially, okay, uh, and this particular condition is not satisfied, I is not equal to 10, so the break statement will not be executed, and what it will print is plus plus I. So it will go to the next statement, which is the printf statement, which is plus plus I. That is, you will get 1 as the output, because it will add this is a pre-increment operation, that is the i's value will increase by 1 first, so i's value has now become 1 instead of 0, and that is what will be printed here. So the first output here will be 1. As you can see, we have, it can be either option C or syntax error. Okay, and syntax error it is not, so it should be option C. From here itself it should be clear, but anyway, I'll run a few more iterations and I'll show you what will happen. So what happens in the second iteration. So in the second iteration, I is equal to 1. When it goes to the second iteration, the value of I is 1. Still this condition is not satisfied, so the break statement will not be executed, and it will do again a plus plus I, that is I's value will become 2 and it will be printed here. Okay, and then it will go to the third iteration. Again the same, this condition is not satisfied, so break statement is not executed. So i's value here, it was 2 initially at the beginning of the third iteration, and when we reach this statement is executed, so it will be 2 plus 1, that is 3, and 3 will be printed. So let's continue this and reach the ninth iteration. What happens in the ninth iteration? As you can see, we'll start the ninth iteration, i's value will be 8, because you can, when we start the ninth iteration, and is that fine? Is that clear to everyone? So again it will be like for the ninth iteration, again this condition is not satisfied because i's value is 8, so it will just add 1 up and it will become 9, and that is what will be printed. So it will be 4, 5, 6, 7, 8, 9 will be printed. And what will happen in the 10th iteration? So in the 10th iteration, you will have i's value initially would be 9. This condition is still false, so break statement will not be executed. Then in this printf statement, i's value will again increase by 1, that it will become 10 and it will be printed as 10. And then we go to the 11th iteration. So in the 11th iteration, what will happen is i's value is initially 10, and here what happens is this condition is satisfied now, so I equal to 10 becomes true. So we break out of this for loop, so this break statement is executed, and this entire the flow of the code uh, comes outside of the for loop, that is the next statement uh, succeeding the for loop, which is the return zero statement. So to come to the return zero, so here the answer will be C, that is 1 to 10 will be printed. Is that clear? Oh. If it had been I plus plus, then initially 0, I think it would have printed up till 9, if I'm not right. Yeah, it would have been D rather than uh, B, because you see in that case I plus plus, it would have incremented after printing, right? So when it would have been I's value would have been 9, it would have printed 9, and then it would have incremented before the next iteration started, it would have incremented it to 10, right? So in that case only till 9, and once it is 10, it would have break would have been executed. So if it was I plus plus, then this would have been the case, like this would have been the answer instead of C. Okay. Okay, so if anyone else doesn't have any doubts, we'll move on to the next question, which is using continue statement, which is we have used a continue statement here. So um, I hope there is no further doubts. Okay, yeah. Okay, so we have three different variables, which is a equals 0, I, and b, and this I is a iterator. Okay, fine. Before that, I told you I would tell you how to write this entire thing as a single for loop, right? So let me do that. So here you can see that this is the conditional that needs to be satisfied for the break statement, and this is the increment that is occurring. So you can write this as I equals 0, that is the initialization, you can include it within the for loop, and then the conditional, you say for the conditional it is uh, I equals 10, this is what we would have written, and then you can write plus plus I or I plus plus. In this for loop it does not make any difference, and you would have printed, say you're going to, okay, so I would have kind of started from 1 here because it's plus plus I, or rather you can not have this and say you can have plus plus I here itself, because you want to print always one higher. So if you write it in this manner, it should still mean the same. Like uh, if you execute this particular for loop, it should give you the same solution. So, for example, for the first iteration, when I is equal to 0, it will check it's not equal to 10, that's fine. Um, and okay, I would say less than equal to 10, right? Otherwise, it wouldn't execute. So, less than equal to 10, then till it is 10, it will execute, and then it will break, it will come outside the first statement. So, are you able to follow the analogy how this came to be this entire thing? Yes. So whatever default value is 0, right? Like the initialized value. It's not some default value. Mm-hmm. Yeah. So not really. Like here, actually, we are not using this for loop. Does not have an iterator. So this when we write in this manner, this I is called an iterator. Okay, because it iterates over a certain range. Like it iterates over 0 to 10 here. Okay, but in this case, there is no iterator for the for loop. like internally there is no iterator. So we are specifying separately, we are writing all this break statement and this conditional statement, which indirectly makes I as a iterator for this for loop, but there is no direct iterator. If you say, if you don't write this break statement and this printf statement, this loop will run forever. Okay, and if uh, yes, yeah, in that case, if you have not initialized a variable before using it, it would give a syntax error, right? Yeah, yeah, it would have given a syntax error because you need to initialize it before. Either you can initialize it inside the for loop by writing, say, for int I is equal to 0. Directly you can initialize it inside the inside the for loop, like while starting the for loop, or you can have a separate initialization, like in this case, int I equals 0. If you don't initialize it and you use this printf statement or this if conditional, it will give a syntax error. Okay, yeah. Okay, fine. So let's see the next question. We have we have this I, which is the iterator, which is going from 0 to 2 in increments of zero point 0.5, and we have this three integer variables that has been defined. That is a, 0, I, and b, and we have tried to print out a after this for loop. So what will be the output for this particular program? So keep something in mind that I is an integer variable. So that is very crucial here. Like the data type of I is integer here. So that is very crucial to remember because that is the key to solving this problem. So here we are doing an increment which is in floating points, okay, and I is an integer variable. So this increment here that we are doing, it will basically be the same as I plus equal to 0 because an integer cannot take any floating point data, that is the any digits after the decimal. So the digit before the decimal is 0. So here what writing this increment condition with the integer iterator, that is I, will basically amount to I plus equal to 0. That means I will not get incremented. Okay, and if I does not get incremented, uh, this particular loop, okay, this particular loop is again an infinite loop. Okay, because it will run forever because there is no increment. I is staying at 0, and it is doing a plus plus continue, a plus plus continue, and so on. Okay, so that is being done infinite number of times because every time I is at 0, because it has been incremented by 0, so it is staying at the value of I is staying at 0, and this condition is always true because 0 is less than 2. So this condition is always true. So this entire loop, it will continue forever. Okay, so if we want to avoid this, we have to define I as a floating point. So if we define I as a floating point, if we had written float of I, then we would have gotten some kind of answer here. But because we use like integer variable I, and we are doing a decimal, like a floating point increment, so here it will be an infinite loop. So here we will not get any output. Okay, is that clear? Oh, okay, so let's see some more examples for flow control statements. Okay, let's see this question first. So this kind of yeah, it's kind of straightforward. So what should be the answer for this? We have a integer a variable I and we have if condition, and we are incrementing the value of I and using a break, and then we are printing the value of I. So what should be the output for this particular code? Okay, why should that be? Right, right. So here it will be compilation error because these are this flow control statements basically can be used only within loops. Okay. So and loops means for loop, while loop, do while loop, and so on. So the flow control statements, that is break and continue, can be used only within this loops, not within if conditions or like branching statements, like you said. So this is why this particular case, in this particular case, it will give a compilation error because we are not supposed to use break inside a if condition. Okay. Okay. So let's go to the next question. This is using the continue statement, and we have an integer variable x which is initialized to 1, and we have a do while loop where we are incrementing the value of x and we are continuing something, and printf we are using a break statement as well. This is our conditional, which is while x less than equal to 2, and we are printing something after this particular do while loop. So what should be the output for this particular code? Okay, yeah, we'll discuss it. Let people get a hold of this. Okay, this, yeah. Okay, so continue, basically what does it do? The continue statement skips any statements after it and goes to the next iteration. Okay, so what happens in the first iteration? Let's break it down into iterations. So in the first iteration, what happens? So the x value of x increases. Okay, so x plus plus basically means when this particular statement is executed and it goes to the next statement, before going to the next statement, it will increment the value of x by 1. So x was 1 and it will increment the value by 1. So x will become 2. Then continue is executed. So once continue is executed, it will skip these two statements. So these are the two statements which come after the continue statement. So it will skip these two statements and it will go to the next loop, like the next iteration. So now the second iteration. So at the end of the iteration, it will check. Before coming to the second iteration, actually, it will check is this x less than equal to 2, which is true. Yes, x is less than equal to 2 because x is 2. So this conditional is satisfied. So it will go to the next iteration. Now in the next iteration, again it will do x plus plus, which is basically x value of x is 2 right now, and it will increment by 1. It will become 3, and it will again execute the continue statement. Once it executes the continue statement, these two statements will be skipped and we'll check the condition. Now this particular condition, if we check, this particular condition will become false because value of x is 3 now, so this conditional becomes false and it will exit the loop. So once it exits the loop, what will it print? After loop, x is 3 basically. That's what it will print. So the answer is D. Is that clear? Okay, fine. So let's now do some miscellaneous kind of exercises. Uh, okay, so we have this integer variable a which is initialized to 1, and we are writing two different if conditions. First is a minus minus, if a minus minus, and we are printing something inside this if block. And then again another, we have another if condition, if plus plus a, and we are printing something inside this block and finally returning 0. So okay, so what will happen when you do this if a minus minus? So what exactly is being executed here? That oh, okay, okay, fine. Let me explain this. There is some clarity required here. Okay, so if a minus minus, so first it will initialize a to 1 and the first if condition is executed. So if a minus minus, what does that translate to? So if a minus minus means it's a post decrement operation, and post decrement operation means basically if of 1, we are writing if of 1 after this condition is evaluated, and this is true, right? Because 1 is a positive, so any positive or negative integer if we write here in the if conditional, it will be it true, and if you write 0 then it will be false. So this statement will be true, and after it is evaluated as true, a's value becomes 0 after this. After this conditional, this first conditional, that is if a minus minus is evaluated, that is it becomes, it's found to be true, then a's value will decrease to 0, and as a result this true statement will be printed. Okay, and then in the next then it will go to the next if condition, that is plus plus a. So now a value is 0 now, and what does if plus plus a basically mean is that it will increment, it's a pre-increment operation. So this was a post decrement operation, and this is a pre-increment operation. Okay, so if plus plus a, basically what it will do, it will increase the value of the variable first, and then it will evaluate the if condition. Okay, so it will increase the value by 1, that is now it again a becomes 1, and then the if condition is evaluated, then, and this is found to be true. So whatever is inside this particular conditional will also be printed. So the answer here will be C. Both the conditions are true, else it will print both the things. Is that clear now how that happens? Okay, let's go to the next question. So we have, the question is what will be the value of I after the execution of the program below. Okay, so I is basically I and j are two different integer variables which have been defined, and we have a for loop with j as the iterator, and it is being incremented every time with the value of I, and inside we are incrementing the value of I with j. So you will have to work this out completely to get a answer here. So I'll wait for some time while you work it out. Meanwhile, you can mute yourself while after you have done, you can just unmute and just speak the answer. That would be good. it should be 11. Okay. 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 Let's work this out. So here I have written the first iteration. In the first iteration, the value of I initially at the starting is 1, and the value of j is 0. And the first step, what it does is it checks with j less than equal to 10. J is less than equal to 10, so that's true. So it will execute whatever is inside this for loop. So I is equal to I plus j, that is 1 plus 0. I's value I still remains as 1, and then after this the increment occurs. So j is equal to 0 plus I, that is 1 here. So j's value become 1. Okay, so now at the starting of the second iteration, the I value is 1, j value is 1. It checks again, j is less than equal to 10. It's still true. Now I is equal to I plus j, that is i's value become 2, and then again the increment will occur, and the value of j will become j plus I, that is j value is 1, I value is 2, so it becomes 3. Now in the third iteration, what happens is we have I as 2 and j as 3. um, Still j is less than equal to 10, that is true. So I will be 2 plus 3, that is 5, and then again the increment will occur. So j is 3 and I is 5, so it will become 8 now. In the fourth iteration, what will happen is initially the value of I is 5 and j is 8, and still j is less than equal to 10, so that is true. So I is equal to I plus j is executed, and that becomes 13, right? And then the increment of j occurs, which is the iterator, and that increments to 21, right? So j becomes 21 now. Is that right? Yeah. Okay, so j becomes 21. So when it starts, before starting the fifth iteration itself, the I value is 13 and j value is 21, but j less than equal to 10 is now false, right? So because this is false, this entire loop will exit, and it will move out of this particular loop, and it will go to the return 0 statement. So the question is asking what is the value of I after the execution of the program. So I's value is 13 here. Is that clear? I guess you did some calculation mistake or something. Okay. Yeah, that's okay. So those who got 12, are you able to see where you made the mistake? Probably somewhere in the calculations, I guess. Just do this in this iteration kind of manner. It is a very simple way. I hope you'll get the answer of 13 here. So here you have to just remember that in a for loop, what happens is first, before starting an iteration, the conditional is checked, and at the end of the iteration, the increment occurs. That's what you need to remember. So uh, you in the previous week's lecture, you might have seen the flowchart for the for loop, right? So there the conditional is checked as soon as the iteration starts. The conditional is checked, and at the end of the iteration the increment occurs. So if you remember that, you can just calculate this and get the answer. Okay. All right. So next, let's move to the next question. Yes. Okay. So compilation error will mostly happen when it's kind of a syntax error that will happen. So if you are, say, accessing, say, I have not defined a here in this particular question. I have not defined a here, and I am directly using a here. So like this conditionals, I am using a. So in that case, it will give us a compilation error, because during compile time, while it is converting, while the compiler converts the code from this high level format to the machine level format, it will find this error, because during compile time, these variables are allotted their memory spaces. If you just go back to week 3 or week two's lectures, you will remember that whenever these variables that we write, they are allotted their spaces in the RAM during compile time. So anything that related to this, say you have not written a variable properly, or you have not declared a variable properly, or maybe you are using some function, maybe without using proper header files, I am using a function. So in all those cases, uh, any error that occurs during the compilation process is a compilation error. Okay, and a runtime error, currently I don't think we have seen any runtime errors till now, but in the next week lectures, when we go to arrays, we'll see runtime errors. There it is possible that while the code is running, you might access, during the execution of the code, you might access some kind of a memory space which is not allocated to you. Okay, it is possible. So in those cases, the program will throw a runtime error that will occur during execution. So when I say it is a compilation error, so it will occur during compile time. Divide by zero, I think it will be a runtime error. Okay, because initial in during compilation, it just stores the variable, but okay, yes, yes, exactly. So a divide by zero will be a runtime error, because while execution it will give you that you are doing a divide by zero, so it will throw an error during the execution. The compilation will happen just fine. Okay, okay, fine. So let's go to the next question. So here we have a if condition, um, and we have, if you remember, this is the and this is the AND logic gate, and this is the OR logic gate, or rather you can say it's just what do you say, it's relational operators, I guess. No, relational was greater than less than, logical operators, right? So this is logical and this is, this both of these are logical ANDs, and this is logical OR, and you have this entire condition. So what exactly will be the output for this code? Okay. Yeah, okay, let's see that. So here 0 and 1. So basically, I'm trying to do a logical AND between a false and a true. And as you know that when you do a AND, logical AND between false and true, it will always give you false, right? So for this entire thing will be false. Okay, now false will be allotted. Okay, fine, let's see the other condition first, and then we have 1 and minus, logical and minus 1. So both of these are true, because like I said that 0 represents a false, but a positive or any positive or negative quantity represents a true. So this is the same as doing a logical AND between true values. So this will be true. Now this entire thing boils down into, now it's basically this, right? Because we evaluated this particular condition and this particular condition, they were in parentheses, so they have high priority. We evaluated them first, and then we saw that the final condition came out to be if false or true. So basically, this is a logical OR operation in which if either is true, the entire value is true. So this will come out to be true. This condition will come out to be true, and if this is true, uh, it will print condition is true. How minus 1? Okay, so it's not like there is no logic as to why minus 1 is treated as true. It's more or less like if you write f of 0, this will be false. So that is something that is set as a convention. So any positive or negative number, if you write, this will be treated as a true. So that is the convention that the programmers have followed for anything other than 0 is a true value. Okay. Okay, so here this entire condition, it came out to be true, so it will print condition is true. Okay, so the answer is option A. Okay, this is correct. Okay, let's see the next question. So here we are using a switch case, and we have a default case and three different cases that we have. So what will be the solution to uh, this particular code? Think about it a bit properly. Why should it be A? Like, uh, okay. Anyone else wants to contest that? Okay. No, actually, the answer here it will be D. Okay, so let's see what happens here. Okay, when you execute this particular switch statement, so inside the switch statement, what is there? It is printf IIT. Okay, so it will print this part. But what exactly happens? What does printf exactly do? When printf, like whenever you write printf, it just shows you the output on your screen, right? That's what you see. But actually, what happens in the background is that it sends the number of characters to the output buffer. Okay, there is an output buffer. You don't need to go into those details. Just that you need to know that the printf statement, it will send the number of characters to the output buffer. Okay, and here the number of characters is 3, right? There are 3 characters here. So here this is equivalent to writing switch of 3. Okay, like this entire thing will boil down to 3. So the value here, it will straight away go to case 3 and it will print Madras. Is that uh, then the default will be printed. If say you had written say IIT IITS or something, or triple IT, say you are writing, instead of this you are writing triple IT. Okay, then in this case it would have been 4 characters, so it would have gone to default. So in that case it would have printed IIT triple IT Guwahati. Okay, so because here there is 3 characters, so what printf does, while printf while printf is being executed, what it does is it sends the number of characters in that particular output to the output buffer, which then prints it to the screen. Okay, now that number of characters will be the input condition for this if statement that we are using, and that being 3, the it will straight away go to case number 3 and it will print Madras. So the answer finally will be option D, which is IIT Madras. Okay. Okay, fine. Let's write that down. So say f percentage f some value. Let me write float a is equal to 54. and I'm printing this A, right? If suppose I had written this, what would have happened? So how many characters will it print here? So it is 54.6 zeros, right? No, it is percentage F. So it will always print this many characters. 6 zeros, there is a decimal, and there is this two numbers before the decimal. So it will print total of 6 to 8 to 9 characters, right? So this is basically 9 characters, and that is what will go through the switch. So here the default will be printed in that case. Okay. Got it, right? Okay. I hope this is clear. So yeah. Okay. So if you are both are integer variables, right? So it will be 5 plus 4, that is 9, and it will print 9.6 zeros after 9. After the decimal point there will be 6 zeros, because you are using percentage f. That means the formatting of the output will be in form of a floating point number. Okay, so it will print 9.0000000, 6 zeros. Okay, if we use percentage d, then it will print just 9. That is, it will format it as an integer, so it will print only 9 there. Okay, so it is a single character. So in this case, if you had written like that, percentage d, say I am writing here percentage d, printf percentage d comma a. So this, here there are only two characters here that would have been printed. So 54 had been printed, and here case 2 would have been executed. Okay, because there is only two characters that is being printed. So you have case 2 here which would have been executed. Uh, is that clear now? Percentage C, if it had been there, then it would have converted into one character, right? So 54, I'm not sure what exactly is the ASCII for 54, but it has to be just one character. So uh, only one character would have been printed, and hence this entire thing would have executed case 1. Percent Percentage S actually is a bit more tricky. Percentage S, it's difficult to say actually. With percentage s, it's, and that also passes the number of characters, but it, because here if 54 itself, uh, if you have defined, you cannot directly write a float a is equal to 54 into percentage s. Okay, you will have to define it as a string first. If you define it as a string, then it will be a string which has two characters. The first character is 5, the second character is 4, and that is what will be printed. You cannot directly do a conversion between a float, like in the formatting you cannot do a conversion directly, writing a float as a percentage s. Yeah, then the number of characters in the string. So say you have, I'm writing C, or let's say I have a string which is say C++. It's a string, right? And I'm printing it with a percentage s, and this, say, some string variable str. So I'm doing this printf. So here there are three characters. So it will take three characters plus one character before. So that I'll cover when we are going to learn strings. So there is always a null character which, sorry, not before, it's after. So there is always a null character which is used to end any string. So here it will be four characters. Okay, so why it will be four characters? It will be covered in the upcoming weeks when we learn strings. Then we'll see this. Okay, so let's go to the next question. So here I have a question for ternary operations, and here, as you can see, it is kind of a nested ternary operation. Okay, so check it out. What the answer should be. So this condition, that is the first condition here, this is a false condition, right? So ternary operation is basically you write the condition, you write put a question mark, this is the true statement. Like if it is true, then it will print this statement, or if it is false, then it will print the statement that is after the colon. Okay, so this is basically this ternary, this is the way to write ternary operators. Okay, so now keeping that in mind, let's see what the answer here will be. Yes, it's a nested ternary operation is occurring. Yeah, it's correct. Answer should be 3 here. So it is, even though it looks like a very complicated statement, it can be simply seen. See, this entire thing is the true statement. So if you evaluate it from left to right, okay, let's go from left to right. And the first, so this is the conditional that we have, that is 4 greater than 8, that is the conditional. It is definitely false. And the part after the question mark is the true statement. So where in this is the true statement? So this entire thing that is coming after this question mark and before the last colon, that will be the true statement. So this entire thing that I have put in parenthesis, that entire thing becomes the true statement, and then uh, after the colon, the one that is there, the statement that is that, as the false statement. So the value of x will be 3 here, because this particular condition is false. So here the value of x will be 3. So that is what the answer is here. Okay. So suppose, but let's say instead of writing 4 greater than 8, uh, let's say the condition had been 8 greater than 4. What would have been the case? Okay, let's check that. What would have happened? Okay, so this is true. Now this entire part has to be violated. Okay. Now, okay, so these are all relational operators. We'll go from left to right for the relational operators based on operator associativity, and this entire conditional we will evaluate. Okay, so first 5 is not equal to 1. This is true, right? Then is less than 5. True means it is 1. Okay, because it's a true value, so it will be converted automatically to 1. So 1 is less than 5, equal to 0. So 1 is less than 5. This is still true, that is it's 1. Okay, equal to 0. This is now false. Okay, so finally it will, this entire thing, it became false. So now this false part, if you can see, 1 was the true part. 1 would have been the answer if it would have been, this last condition would have been true, then 1 would have been the answer, but because it is false, the value will be the value of x will be 2. So whoever said 2 just now, it's correct. So x will be 2 in this case. Okay, okay. I hope that's clear. So we'll move to the next question. So the next question is, we have two different variables k and j, which is of short int, and then we have a while condition using both k and j, and we are incrementing some values and printing it. So What should be the answer? This is pretty straightforward, so I think you should be able to answer pretty immediately. Just run through the iterations quickly and get the answer. Is it? Okay, let's see what happens. Okay, let's say first iteration. While the first iteration starts, the value of k is 1 and j is 1. Both conditions are satisfied. K is less than equal to 4 is also true, and j is less than equal to 3 is also true. So both are true, so overall it is true. Now k is incremented by 2, so k becomes 3, and j is incremented by 1, so it becomes 2. Right? Now again it comes to the second iteration now. Now in the second iteration, what happens? The value of k is 3 and j is 2. Both conditions are still satisfied, so this entire conditional is true. So the value of k will increase by 2, it will become 5, and the value of j will increase by 1, it will become 3. Now it will come to the third iteration. In the third iteration, the value of k is 5 and the value of j is 3. The first condition is false now. K is not less than equal to 4. So this part becomes false. But j is less than equal to 3 is still true. So because we are using a logical OR here, if either of the statements are true, then the entire condition is true. So this condition will still be true because j is equal to 3 right now. So this the second condition is true. Hence the entire conditional is true. Now again the value of k is incremented by 2, it will become 7, and the value of j is incremented by 1, it will become 4. So once that happens, before the fourth iteration starts, it will again check the condition. K has the value of 7, so the first condition is false. The second condition, has the value of 4. The second condition is also false. So both conditions are false. Hence, the entire conditional is false, and the while loop will exit. And while loop will exit, and it will print. So what will it print? K comma j, that is 7 comma 4. So answer here will be B. Okay, I think this this should be pretty clear. If anyone has any doubts, you can just ask me. Okay. Okay. So finally, we'll just visit a coding question. We'll discuss how to exactly do this particular question, like what should be the logic behind this, behind answering this particular question. And while I'm uploading the PDF, when I provide the PDF, the program will be added here. Instead of the logic, I'll add the program, so you can just refer that, or you can check it out on the internet as well. It's pretty straightforward to get. So this question is that write a code to enter a 3-digit integer, 3-digit positive integer, I would say, not just integer, it's a positive integer, and check if it's an Armstrong number. Okay, so Armstrong number basically means that the sum of the digits raised to the power of the total number of digits is equal to the number. I don't remember any Armstrong number right off the bat, but let me give you an example of how it is done. So, say my number is 12, so the total number of digits is 2. So, I'll check that if 1 square plus 2 square, I'll add this 2, and that gives me 5, right? And this is not equal to 2, so 12 is not an Armstrong number. Okay. Now in this case, we have said clearly that a 3-digit integer. So say I am taking 123. So 1 cubed plus 2 cube plus 3 cube. So we'll calculate this. If this is equal to 123, then 123 is a Armstrong number, else not. So we know that the number of digits is 3. Now, how do we extract the digits individually? So we use a while loop. Okay, we can also use a for loop. So what we will do, say uh, n is a integer that we have that the user has inputted, and we'll just define another variable int m, which we will save the value of n for later on, because finally we have to compare it, right? And while using the while loop, it will change the value of the variable, so we will prefer not using the same variable. Okay, so m is, while m is greater than 0, so my integer, I need to extract each of the digits, and I need to perform a cubic multiplication, cubic power, and because it's a 3-digit number, I need to calculate a cubic power. So to get the last digit, we'll divide it by 10 and see the remainder. So 123 when divided by 10, so you'll have the number 3, and then I have a sum variable which I have defined to 0, so like initialized to 0, and what we will do is we will do sum is equal to sum plus, uh, you can use the power function if you want, x comma 3, or you can just multiply x into x into x, okay, thrice. So this is the sum, and what happens is we will do m is equal to m by 10. So this is our code. So how this came about to be? So what we need to do first, you need to extract the number of digits, right? Extract the digits. So I'll do a percentage calculation, percentage 10. So that is the remainder operation, which will give me the value of 3 here, and I will do a cube of 3. I will add it to sum, which is 0, and now it is, say, I think 27, right? So it is 27 now. Now next what happens is I'll divide 123 by 10. It becomes 12.3, but because m is an integer, it will store only 12. Okay. Now in the next iteration, m is still greater than 0 right now. So this is in the first iteration. What happens in the second iteration is that now the value of m is 12. Okay, so let me just write this down. X, this is m. Okay, so m is 12 now, and now again we need to extract the last digit. So 12 percentage 10, that will give us the last digit, which is 2, and our sum is 27 from earlier, and we are adding with it 2 to the power 3, because cubic sum, right? So it will be added up with 8, that makes it 35, and then what we do is 12 by 10, so it is basically 1.2, but m being an integer, it will store 1. Okay, now still m is greater than 0, so conditional is still satisfied. It will go for a third iteration. Now m is 1 here, and when I do 1 percentage 10, the remainder itself is 1, the quotient becomes 0. So the sum is 35, and I add with it 1 cube, that makes it 36, and m we do m by 10, so 1 by 10, which is 0.1, which is basically 0 if we take the integer. Now m becomes 0, and we have also extracted each of the digits, and we have done a cubic sum of all the digits. So in that case, the loop should exit by this point. So the conditional here should be m greater than 0. Only then it will run till m is greater than 0. Once m hits 0, that is, we have extracted all the digits, the loop will exit. Okay. So in this case, after we have done this, so sum we found out to be 36. So now we will write a condition that if sum equal to n, that is the number that was the user input, this is n that I have taken, then it is a Armstrong number. Okay. Else it is not an Armstrong number. . so overall the logic of the code should be this. Now I'll show you. Is there any doubt regarding the logic of the code? Okay, so now I'll go to the code. So this is the code. I have used this power function. So the power function is defined under the math header file. So I need to include the math header file as well if I want to use the power function. Or you could just write x into x into x because it's a 3-digit number that you know. So you could directly write that. Or because I have used a power function here, I'm including the math header file here. Okay. So I'm asking for an input from the integer integer input from the user, and I'm saving it in the variable n, and I'm creating another variable m, and I'm storing the value of n in m, and I'm using this n and calculating. I'm setting the sum to 0 and defining all these variables, and x is something that I've written exactly this thing earlier. That is, I'm extracting the digits here. The last digit is being extracted, the last digit of n percentage 10. Then we are adding the power. We are doing a power of 3 on x, and we are adding that to the value of sum, and we are dividing the value by value of n by 10 in order to reduce it by one digit. And finally, when this entire while loop ends, we will have uh, we'll check whether the sum which was found, which we have calculated, is equal to the initial value that was entered by the user. So if m is equals sum, then we'll say that it is a Armstrong number. Otherwise, if it is not equals sum, then it is not an Armstrong number. Okay, so uh, this will be the code for Armstrong number. I hope that's clear to you. And I think you can use the same kind of thinking for extracting the digits, because here we are extracting the digits of a number, right? And then we are doing some calculations on the digits. So you can think of the extraction part itself. I think that is one of the assignment questions that you have. So you can just take some inspiration from here. Okay. Okay. So that's all I have. That's all the material for today. Yes. This PPT is actually shared. Like you can find it under that. I share it immediately after the meeting, so you'll be able to find it there. There is a problem solving entry in the pro. What? Yes, yeah. In the problem solving section, there is a link there. You can access all the PDFs from there. Okay, someone did ask regarding the short INT. What is the need to take INT as a short INT? There is no need as such in that particular question to take it as a short INT. But taking it as a short INT, basically it limits the number of values that it can take, right? Because short has a much smaller range of values that it can take compared to INT. So that is the only case here. Here it makes no sense because we are not breaching any of those limits that either short or INT has. So here it does not make any sense. You could have simply taken INT itself. There is no reason as such to take short INT here. Okay. Uh, I hope that is clear for uh, Sai Teja. Okay. And no, in C plus plus indentation does not matter. That is, in Python it matters, but in C++ it does not matter. I'm not very familiar with JavaScript, so I can't answer that. But in Java also, I don't think it matters. Indentation does not matter in Java. Yeah, maybe I'm not familiar with JavaScript, so I can't answer for that. But C++, Java, definitely I know that it does not matter. Okay, fine. Let's So we'll be ending this session today at this point. We'll meet again. If there are any changes to the timing, I'll inform you. Otherwise, we'll meet at the same time uh, next Tuesday, 6 to 7. Okay. Uh, okay. Thank you everyone for joining.